Welcome to the Falling Walls Plenary Table, unlocking pathways to a sustainable hydrogen economy.
Good afternoon to one and all, to everyone joining us today in person and online for the Falling Walls Circle 2021 Plenary Table session, Unlocking Pathways to a Sustainable Hydrogen Economy. So my name is Juliana Chan. I'm a science journalist and the publisher of Asian Scientist magazine based out of Singapore, and we report on science and technology news from the Asian region. It's my great pleasure to introduce and welcome our four speakers today as they enter and walk onto the stage. So first, let me invite Mr. Marius Bernd, Executive Vice President of Sasol, an integrated energy and chemical company headquartered in South Africa. And next we have Ambassador Philippe Green, Australian Ambassador to Germany, Switzerland, and Liechtenstein. Next we have Professor Bernd Rech, Scientific Director of Helmholtz-Zentrum, Berlin. And finally, we have President Philippe Tanguy, President of Polytechnique Montreal. All right, welcome speakers. I can think of no better opportunity to discuss climate change solutions and energy solutions right now, because there's another conference, a very important one, COP26, the 2021 United Nations Climate Change Conference that's also taking place right now in Scotland. So we urgently need to reduce greenhouse gas emissions, and the key to this is in massively increasing the share of renewable energies and integrating them better into the grid. One such climate neutral technology is green hydrogen. And today, I'll invite the four of you to give an opening statement on the question, what needs to be done in research, society, or politics to accelerate the transition towards a sustainable hydrogen economy? So we will then, after that, engage in a free discussion among ourselves. Feel free to talk to each other. And at about the 35-minute mark, we will open it up to the floor to give us their comments and questions. So shall we begin? Sir, on to you.
Thank you so much, Juliana. Thank you for the question and the opportunity. I think certainly when you look at hydrogen, I mean, it's certainly one of the key elements that's required for this energy transition that we have to embark upon. There are certain hard-to-abate industries and sectors that are really going to benefit from a prosperous green hydrogen economy. And I think for us, the challenge is really I think, three dimensions, if I can say that. I want to start off by saying the affordability of green hydrogen is going to be very critical in unlocking these opportunities. And it's to be supported by regulatory, by research and technology and innovation, allowing us to really apply the hydrogen, not only in the energy sector, but also as a building block into the petrochemicals. And perhaps that's, for me, the one that stands out the most. But we cannot forget accessibility, the ability to have access to green hydrogen, and hydrogen as a whole. And I think for me, the last one, and we can speak a bit later on, also the acceptability, I think, is going to be very important by society and everybody that plays into this environment. Thanks.
Thank you. Philippe?
Okay, thank you, Juliana. Well, for me, the green hydrogen project have three characteristics to be successful. One is to be attractive. What I mean by attractive, they must have impact. And there is an issue of scalability again, and accessibility. It's very, very important. I mean, if you want to make a difference. The second one is those projects must be investable. And what I mean by this is we must have the right legal framework, certainly stable one. And certainly there are issues of supply chain management which have to be resolved. And you know, it's still a burgeoning industry. We have to realize that. Not hydrogen, but green hydrogen, of course. And the third one is that those projects must be bankable. And you know, the capital markets now are evolving very quickly towards being careful where they put their money. And so there is certainly some pressure from the civil society on this, the customers and so on. So, so in fact, they look at the risk of investing into something that would not be acceptable from the pension funds and so on. So this one is also important. So three things: attractivity, investability, bankability.
Thank you. Ambassador?
So the world will need molecular energy like green hydrogen because not all of the industries that we need to decarbonize can be fueled simply by electricity. There are some parts of our economy, long-distance transport, ship transport, eventually aviation, certainly chemicals industry, and industrial processes like steelmaking, that are going to need powerful molecular energy. So we're going to need something like hydrogen, and there's nothing else that's obvious on the horizon at the moment. The principal problem at the moment is cost. Hydrogen is just several times more costly than fossil fuels. So I think the key answer to your question is what needs to be done to bring price down. The first thing is scale. We need to operate hydrogen plants at scale in a way that we have never done, and we need to produce the inputs to hydrogen production at scale, producing electrolyzers at scale rather than the cottage industry, to be honest, that it currently is. Secondly, we need technological improvements in that part of the hydrogen supply chain which is not yet mature. And in particular, that relates to transport, how you get hydrogen around the globe, because that's going to be absolutely crucial. The third thing that we need to do about price is to manage the gap between producers and users. The way I see it, potential off-takers of hydrogen are not yet ready to make the changes to their business processes to use hydrogen as an input because they're not yet sure that it's going to be available at a reasonable price and in the requisite amount. And producers aren't yet ready to commit to produce because they're not yet sure that off-takers will want it at what price. We need to solve the gap between producers and off-takers. Government needs to be a part of that. That's why my government is supporting the development of new hydrogen hubs, which will bring down price. The German government is supporting auctions, which will even out the cost between those who are prepared to produce and those who are prepared to use hydrogen. So they're the three things I want: scale, technological improvement, and closing the gap between producers and off-takers.
Thank you. Bernd?
Thanks, Juliana. I think first thinking what happens parallel in Glasgow, failing to decarbonize our economy is not an option. I think we know there's no planet B. So the global clean energy transition needs a massive expansion of renewable energies, and hydrogen has to play a key role, as my colleagues already mentioned, to decarbonize hard-to-abate sectors like heat, industry, and mobility, and by providing energy storage solutions. I think research is a strategic element there. We need breakthrough innovations for sustainable key technologies to bridge the gap the ambassador just mentioned, and we need strategic partnerships between academia and industry. They will be crucial, and we need increased international cooperation. And I'm convinced that we need to act now, local, but certainly global, to make this happen.
Thank you. So, thank you for your opening statements to my four speakers. So, we will now enter a free discussion among ourselves. I've thought about how to tackle this very complex topic, and the way I've thought to do so is to start with something I'm very comfortable with, the science and technology at the core of it. Then I want to move on to commercial business applications, which we have representatives for, and then next to take a very big picture of all this, what is Germany's interest in these international partnerships, and how can the entire world benefit from green hydrogen. So I'm looking at you, Bernd, because, well, you're the host, Helmholtz, and since we are in Berlin, in the heart of Germany, I'm very curious to find out what are Germany's interests specifically in the green hydrogen economy, and how is Helmholtz-Zentrum Berlin and the other centers contributing to this goal?
I think the big interest is, and you mentioned the word, is green hydrogen, so hydrogen which is prepared or produced from renewable electricity. I think if you look on the German situation, we are a country, we have some sunlight in the summer, we have quite a lot of wind energy, but certainly everything is fluctuating, and we have a strong industry. So what we need to do is to transform our system partly to renewable energies. We can only use part of the energy what we produce by ourselves, but we need global cooperation as we have it at also now. And one way is certainly to get, let's say, green hydrogen from other countries. Some examples are sitting also around the table, where there is more sunlight, more solar energy. But certainly Germany is a technology country. We have big companies, we have industries, and we are very strong in the scientific field in catalysis, which is a key field to come to hydrogen solutions, and also in the development of solar cells or wind turbines, for example. So this is one issue why Germany is very much interested in, and I'm coming from from the Helmholtz-Zentrum Berlin for materials and energy. So we cooperate, for example, in a new project with the Max Planck Society, where we try to develop new types of catalysts based on thin films. We are in cooperation with Sessel company, for example. And we are a part of the big Helmholtz Association. So our friends in Karlsruhe, Jülich, we look on the transport, the ambassador mentioned, of hydrogen by liquid sources, for example, so liquid organic hydrogen carriers. We're thinking about new ways how hydrogen can be generated. And in this context, I'm very happy to be here and step in again.
So, Bernd, are these all proof of concept, experimental studies? Are there any applications that we can already see outside, out there beyond the labs?
Certainly, there are a lot of demonstration projects available. There's a lot of hydrogen already used in chemical industry, so it's not a new molecule.
Right.
And there are examples, for like trains which are now running on hydrogen.
There are trains in Germany running on hydrogen.
But only first demonstration trains. There are one or two. Or
two trains.
And there are more to come. Certainly we have had already since long projects on driving cars with hydrogen. But I think especially in the mobility sector, for heavy transport, it's an important issue. But we need to use hydrogen, especially also for our large industries. So to transfer the chemical industry. So there's companies like BASF are certainly looking clearly into hydrogen. So we have different steps, but we also need to go for new and better technologies. So we have technologies to start today, but to bring the costs down, we need both. We need a massive expansion of the market to benefit from the learning curves, but we also need new technologies to further drive these learning curves.
Can I just comment on the place that Germany holds in our calculations? I mean, we've had a hydrogen strategy out there for several years now. We want to be one of the biggest, if not the biggest, exporters of hydrogen in the world in the future. And for us, Germany is an absolutely key partner. And that's not just because it's going to have demand for green hydrogen, and we're going to have a lot of supply. It's very much because of the technology side. Now, we have plenty of good scientists, good on photovoltaics and so on, but we do not have the industrial manufacturing capability that Germany's got. So every time I talk to people who are building new hydrogen plants in Australia, it's the same German firms whose names come up, ThyssenKrupp, Linde, Siemens Energy. They're the ones who are going to supply vast amounts of plant and equipment to drive the scale that we need in our hydrogen plants in the future.
I see a lot of partnerships at the table. We can actually discuss that. There's also Canada involved in this, and in South Africa as well. Now, moving on to businesses, and I'm looking at you, Marius. For businesses to adopt green hydrogen technology, it must make business sense. And we've mentioned earlier in the opening statement about the efficiency, the cost efficiency of doing so. And clearly that's a stumbling block for this technology. So what is you're at Sasol, you're working actively on this, but what is the return on investment that Sasol predicts for green hydrogen?
Juliana, that's a very good question, especially in the fairly nascent period that we're in the early stages. And I think both the ambassador and the professors referred to currently the cost to produce hydrogen, green hydrogen, especially for which is a building block for our chemical industry and petroleum industry that we anticipate to embark on a sustainable way. Obviously, that net cost at the moment is higher than we can get that premium. So we are challenged, and we truly believe that the cost will come down in terms of, as we've seen in renewable energy over the last 10 years, significant cost reductions. So this economy that we're embarking upon requires that investment in technology. It requires that efficiency along the whole ecosystem, right from the production of renewable energy to the production of green hydrogen, but then also very critical, the storage, the transport, and then making that available at the point of use. So the technology advancements that we require, and it's not only in the research and development side, but it's also in the innovation. And we've seen a lot of opportunity coming through startups, really, fueling this whole opportunity that's out there. But how do we make sure that we get that whole value chain to be competitive? And I think that's going to be our challenge. So we are very early in our transition. In South Africa, we only recently, over the last 10 years, embarked on fair-scale renewable energy. We've got a hydrogen economy strategy for the country out there. We're all very keen to participate, but it is all about how do we get that cost down. And that's going to be a combination of technology advancements. We see that. We see also off-takers taking a stake into this. We can't do this without a long-term price certainty of where we're going to go. Obviously, regulators play a very critical role in that. Regulators play a role in terms of giving certainty on policy. We are very interested, for example, in sustainable aviation fuels. And we've seen in recent period just the announcement from the EU Commission in that regard. That type of comfort and certainty is very critical. But we have to be much more proactive. We don't have time, so we don't have time for the transitional, almost sequential activity take place. So between public, private, and all these research institutes that we have to get that together and really be very effective across the ecosystem. So our returns on investment at the moment, we see that only to really come to the fore from a profitable point of view towards the end of this decade. In the period up to now, we need support, funding, and incentives to help us make the technology work for us so that when we get to the point of scale, as the ambassador said, that we really need to go big, we have to have, at that stage, a certainty that the integrated nature of the technology actually works well for us.
I'm glad, Marius, that you mentioned about startups. I didn't even think of them because when I think of these kind of large-scale energy transitions, I think of big companies like Sasol. What is the startup scene like in your respective countries where green hydrogen is concerned?
Maybe just give one example. There's a startup company which is on our campus in Berlin-Adlershof. It's called Home Power Solutions. They are really looking for a hydrogen solution for storage, combining PV on the roof with electrolyzers and hydrogen storage. It's just one example of many who think on the small scale to hydrogen solutions.
Yeah, well, I've got one example too, and it's called Lavo, and it's a great young Australian company which is producing the capability for hydrogen to be used for domestic uses, domestic storage of hydrogen. A hydrogen bike. I'm even going to have in my embassy in January a hydrogen barbecue, which will allow us to produce cooked meat and vegetables with a clean fuel. So Lavo is a great young Australian company. It's got a big future.
If you are an Australian hydrogen startup, you have to make an hydrogen-powered barbecue.
There's a South African at the table. You know, I think there should be.
It's a priority. There's a national priority, isn't it?
Absolutely.
Well, you know, I learned this morning at the first plenary table that only 15% of climate change research takes place in the global south. And I guess, you know, energy research as well. You know, this is for any of the speakers. What do we need to get the world on board for this? You know, we can't have this as a first world technology, a European technology. So, you know, asking questions about how do we get everyone included in this revolution?
I'll take a first step, and then now I can. I think when you look at our environment in South Africa, I think certainly we have to get our universities and our research institutes to obviously be able to participate in this challenge. You know, so the funding requirement, the focus, the support from public and private to do that. But I think the bigger challenge is, and I think the ambassador alluded to that, you know, a lot of the heartbeat of technology sits in the country that we sit here today. I mean, and Northwest Europe and the US, China, those are areas, and Japan are really at the forefront of some of these advancements. So our plea are for collaboration. Now, how do we bring really great universities in South Africa, but perhaps haven't got perhaps that leadership in certain areas? How do we bring them in contact with some of these leading institutes that we have globally that are already advancing into a certain extent? So I think it's all about collaboration. It's all about partnering. I think that's going to be the solution to make sure we don't have the developing countries staying behind this very important journey.
Okay.
If I can make the very obvious point that there are huge opportunities here for developing countries. Any developing country which has large opportunities to produce hydropower, any developing country which has massive wind and sun capabilities, and there are many of them, I don't need to mention them here, has an opportunity to be part of a hydrogen future. And we in Australia welcome that. You know, we think we are going to need very large quantities of green hydrogen for the future. We want to be a part of that, but there'll be a place for many. And as ever, the speed with which countries are prepared to uptake, to work with business, to allow the science to flow into their countries will determine who will be in the lead in this and who won't. But there's any number of opportunities for developing countries.
I may want to comment on this as well. Of course, I mean, many countries, depending on their location, can have access to a large amount of renewable energy. For me, the problem is not there. The problem is being able to get electrolyzers. And right now, the largest electrolyzer that you can get on the market, I mean, for the modern ones, that is a proton electromembrane, are 5 megawatt. 5 megawatt mean that you manufacture 750 tons per year of hydrogen, which is even not a small peanut. Okay? So we are talking about scales which are completely different of what we used to have. You know, in the field of batteries, everybody is talking about gigascale factory. That's the same with hydrogen. And we are very far from there. Right now, what we do are numbering up. That is, we stack up 5 megawatt systems to make larger systems. But larger systems are still very small systems. So where are the hurdles? Well, the hurdles, there are several. One are the membranes. We are not able to make large membranes. That's one thing. And Bernd can certainly help us on this. Second one is catalyst. It's still very important. Nanoscale catalysts are important. There is a team in Queensland working on this, Titan Hydrogen. They are working very well. We hope it will work better than what even they claim. They claim that they can improve significantly the efficiency of the electrolyzers and the fuel cells, so we'll see. But the problem are there. The second problem that we have not talked about yet is manpower. We need to train people. And when you look at the amount of people who are trained in hydrogen right now at universities, it's close to zero. People can be trained in chemical engineering in the field of maybe the traditional oil and gas, but still it's not very attractive anymore for reasons that I don't have to explain. Meaning that at the end of the day, even the chem students have not much, I would say, opening to the field of gases and then hydrogen. So we start from scratch. And we have only to rely right now on the gas suppliers to be able to provide the manpower. And you know, to educate engineers and technicians first and engineers, well, the minimum is 5 to 6 years. So if we are really serious about achieving a target in 2030, we better start right now, because we have 8 years in front of us.
Wow. That's not very long.
No, it's not very long.
I would bring in another aspect still. I think it's very important what you said, but if you think about how to transform the world, we also have to find solutions for different places. And this is why we need to talk about infrastructures. And when I talk to my colleagues and friends at Cape Town University, and they're thinking about solutions for Africa, for example, then a lot is liquid petroleum gas. So other sources which they use, and the question is how we transfer the hydrogen then, for example, via CO2, which is captured to this kind of carriers which people are used to use and where the infrastructure structures are existing. And I think this is also a very important question, where we set up new infrastructures or where we use solutions or go for solutions which already fit to existing infrastructures. I think this is a lot with regulations, but it has a lot to do with how economies work. And I don't know if there's a hydrogen barbecue or if we also still find some clean...
This is a very valid point. And we're talking about hydrogen, but okay, generating hydrogen is not a big thing now. The thing is what you do with it. If you can use it right at the spot of production, fine. If now you have to transport it, it's another story. What are you going to do? Do you use an energy carrier? Do you use, liquefied hydrogen, like which is advocated in Australia? Do you use ammonia as a carrier or something else? Methanol, we recycle CO2, formic acid, and there are many of those. This is, again, an open question. And those carriers now comes with their, I would say, their own safety issues. Ammonia is nice, but ammonia, you don't give that in the end of the individuals usually. We deal that at the industrial level. So for me, hydrogen is the easy part. The demand side, well, it's dictated by industry, and the chemical industry is an obvious one to start with, and probably heavy mobility is another one. But in between, that is infrastructure, logistics, is something that has to be dealt with very carefully. And it's not straightforward.
Excuse me, Philippe.
Oh, yeah, sure.
I just wanted to jump in and say Philippe's exactly right here. And for a country like Australia, which is a long way from many users of hydrogen, transport is going to be a huge issue. So the bilateral feasibility study on a supply chain between Australia and Germany in green hydrogen had looked specifically at this issue. And the conclusion that they come to is that inside about 2,000 kilometres, the cheapest, most efficient way of transporting hydrogen is going to be via pipeline, and that's unbeatable. It has some rigidities because, of course, once you've laid a pipeline, you can't get it to different ports, but that will obviously have a price advantage. But beyond that distance, you're going to be looking at other methods of transport, and the natural one is shipborne transport. Now, Philippe's dead right. Shipborne transport using cryogenically frozen or cold green hydrogen is very expensive. Green ammonia, the technology exists, and that's a big opportunity. As he says, there are some issues around the utilisation of it. It's a tough chemical to use. But the other thing is, I mean, one of the holy grails for us is finding a way to crack the hydrogen, the green ammonia, once it arrives at the destination, and turn it back into pure hydrogen. And this is where our equivalent of Fraunhofer, it's called the CSIRO in Australia, has developed a metal membrane technology using vanadium to be able to crack the green ammonia back into its constituent parts so we can use green hydrogen. Only at the scale of the lab so far, so we're not ready to do this at industrial scale, but it gives you an idea of a future where you might be able to fix the transport problem around green hydrogen.
Okay. I don't like the idea of cracking down ammonia back to hydrogen. Use ammonia as such.
Well, at this point, we have 3 minutes to go. Would we like to start the open? Okay. Well, I guess we have 3 minutes to go. I do have a interesting. I did find this interesting because we were chatting earlier and we were talking about this global energy pie, and it seems to me that there's all these jostling, clean technologies. They don't exist individually. They kind of support each other in some ways. Sometimes the infrastructure of one can help the other, and then sometimes when it's like not sunny or not windy, you can supplant it with another. So how do you see the entire mix of clean technologies, maybe from the commercial, the angle, and of course, everyone else is welcome to add on to that.
Yeah, I think renewable energy is absolutely great. I think the issue is about your continuous load factor. So how much can you continuously depend on? Because if you start to have green hydrogen as a feedstock to petrochemicals, you need a 24/7 type of operations. So I think this is where the importance of transport and storage really becomes so critical for us. So I think the global network around around renewable energy is going to be very important. I think we have said around the table here, how do we actually build this almost infrastructure globally of moving hydrogen from one area to the other? In some it will be pipelines, and others there will be marine transport, most likely either through hydrogen or through green ammonia. But I think the reality is that it will require almost a global plan for us to work together, because one country in its own is going to be facing all the challenge of going individually, getting all the cost on it. So I think that almost global pact that we have to think through, and so how do we put up this whole system to support the industry is going to be very critical. Just from our side, for the petrochemical environment, it's really important that we get that cost really very competitive, but also reliably. I think at the point of use, going to be very critical for us. The last thing I want to just add is the safety. So it's new for everybody, and we have to make sure that as an industry we don't have undue safety incidences and requirements. So standards is going to be very critical for us from day one to be able to play in this industry.
Maybe I just want to step in. I think if you listen to us, you see and learn that there are certainly a lot of issues, a lot of challenges, but I think there are also a lot of technical solutions around, and better solutions will come. So I'm quite convinced that we have no other opportunity than to go to a sustainable hydrogen economy. So that it's not only an opportunity, it will become a necessity. And I think this is where we agree here. And we have to find those solutions. We have to find it in cooperation, in scientific cooperations, and in a very quick transfer, and in global cooperation. I think it's a global problem what we are facing all.
At this point, I would like to open the floor to questions from the audience, of course those in person and also those joining us live.
Yes, and let's start with one of the digital questions. And this is a question that I had myself, so I'm very happy to read it out. On what timeline do we think we're actually going to be able to solve these problems for these large-scale applications we're talking about, such as heavy industry, heavy transportation? And is that timescale actually compatible with what we know we need to do to cut emissions to stay under 1.5 degrees Celsius of global warming?
What is the timeline for this?
Well,
Who wants to commit to that answer?
Well, right now, I would say situation is that we have many countries having pilot projects, either on intensive or heavy-duty mobility or on industrial use for converting CO2, for instance, recycled CO2 into chemical products. Now, in chemical engineering, I know that from the idea, that is from the lab to the plant, you know, below 10 years, impossible. Sometimes it's 20 years. So I believe we do not have 20 years in front of us. It's not brand new, and I agree with you, Bernd. So the things are already established. 2030 is short. It's quite short.
I would say what is important, and I said it in the beginning, we need to start now. We need to expand we need much more renewable energy available.
Yep.
At the moment, we are not able to produce all the green hydrogen. So it needs, for the hydrogen solutions, we need to start with hydrogen which is available, think about how to develop the technology and increase it. It will be step by step, but to start now, and we need to shape our curve in the CO2 emissions. So this is
because you are living in Germany. You know, in Quebec, we have almost 40 terawatt-hours excess electricity. So with this, we can already manufacture 800,000 tons a year of hydrogen if we want. So, of course, it really depends on the context. And in Australia as well, there is a lot of energy available. I understand that Europe is quite restricted on this. That's very clear. That's a good market for us.
Look, there's going to be a lot of demand. There's going to be a lot of competition, and we welcome that. And there's a lot of opportunities for very different sorts of players. So our government's goal is encapsulated in the phrase H2 under 2. That means being able to produce a kilogram of hydrogen under 2 Australian dollars, and that's nice for all of you who don't know our currency because it's cheaper than the US dollar. So we think that can be achieved within a few years, and I'd be very disappointed if that wasn't possible by 2030.
Let's turn to our physical audience and see if any of our audience here have a question. Yes, we have one just here, and I'll remind the audience to keep their questions brief so we have time for as many as possible.
Okay, thank you. My name. I thought you were going to say that I should keep my mask on. My question is, you have spoken a lot about costs, and this was always the argument for the market for photovoltaics too, until it finally reached, after decades of development, lowest cost, kilowatt-hour cost available. In your scenarios, maybe the question should be to Sasol first, or maybe to Australia, Australian ambassador. In your scenarios, if the true cost of fossil fuels, or whatever, if the cost of fossil fuels would be raised a little bit by CO2 tax or by other burdens, where would you see a faster tipping point for this development?
Yeah, certainly I think if you look at fossil fuels and you add carbon taxes that would potentially come onto that, you see that curve is obviously to break is much quicker and much slower. I think still the reference of Ambassador from $2 to Australian dollars, I think it starts to become the very important point for us. You know, we talk about in our business about 1.5 US dollars to the kilogram. And I think earlier today I heard the US has reconfirmed their target of having in 10 years hydrogen at $1 to the kilogram. But I think between 2 and 1.5, that becomes really very attractive to to current industries to be able to compete. And that's not taking high premiums on the product into consideration, really just to compete with jet fuel plus the carbon, fossil fuel plus the carbon taxes that we expect on that.
Can I look at it from the other side, which is that governments like mine, governments like Germany's, are putting real money into subsidising the production or the start of a hydrogen industry. In Australia's case, that's 1.9 billion Australian dollars, which we expect will leverage about $30 billion worth of investment once you throw in the support from business and our state governments, which will start to develop serious hydrogen hubs in Australia. So I think that is also going to be a very big part of the picture, is the way in which we support the early part of the industry. The other thing, I referred to it earlier, but I mean, the German government deserves an enormous amount of credit for this. Germany is planning to run auctions of hydrogen, which will even out the cost between what German off-takers are prepared to pay and the cost at which producers are able to land green hydrogen in Germany. Now, that will start to break this gap between producers and off-takers. It can't go on forever. That's obviously got to be a transition, but it will start to commodify green hydrogen for the future.
Sure. Given a lot of the technological and cost advances of battery technologies over the past years, past decades, does that jeopardize in any way the role of hydrogen in some of these more mundane settings, for example, in the home or in cars or in electric bikes or in barbecues?
Yeah, I think this discussion is, sometimes we have a lot of dialogue around it, but it's really an and discussion. We need it all. If we want to go to 1.5 degrees below, we're going to need all of it. We're going to need the acceleration of EVs and battery technology, but we're also going to need the acceleration of the green hydrogen economy. It's absolutely a must that all of that must work together, and that's certainly where we come from.
I fully agree. So we cannot do it by electricity only. I think electricity needs to increase. And if you look on the numbers, what is expected, there will be a big increase in the electrification of the industry, but we still need the chemicals. We have the chemical industry. And for the energy density of chemical energy carriers cannot be beaten. So for an industrial life, we need them.
Yes, certainly. We should not oppose batteries and hydrogen. I mean, for me, they are really two solutions for the same global problem. Hydrogen is a chemical element. It's a building block for the chemical industry. And you have industries, I mean, we need those molecules. So, and an electron is not going to provide the molecule we need. So hydrogen is the way to go. I mean, period. Or if not, we stop industry. But we are not going very far with that.
Let's take one more question from the online audience. What do you see as the role of small and medium enterprises in the new hydrogen economy, or is this purely the domain for larger organizations, larger enterprises?
How can small companies participate in this?
I think, I don't want to use the word reindustrialization, but that's certainly what we're going to see in certain areas. And there's a place for a lot of new entrants. We've already seen in Germany now, but also in South Africa, new players come into the space. I think we should be open to that. They bring the opportunity to be agile, to be quick, and to be helping us in areas perhaps where a corporate, for example, don't have the expertise to go into, and perhaps which they can bring and facilitate for us. We certainly see them as very important. And I think we must really think about partnering, I think, across the spectrum of medium and mid-size, also to participate in the whole value chain. It's quite an extensive value chain to participate in.
One more answer before our time is up.
Maybe just to add, if we have a more distributed energy system, there's also a possibility for distributed chemical companies, for example, so smaller solutions going. And this is something where new products and new ideas from small enterprises can fit in the system.
All right, our time is up for the question and answer round. Thank you, Adam, for moderating that. Well, today, to wrap up, our 4 energy experts and leaders discussed the promising rise of the green hydrogen economy. We talked about timelines. We seem to have less than a decade to solve this. We talked about how it's already been implemented beyond the lab in trains, in cars, and barbecues, of course. And we talked about how startups can get in on this, not just large established multinationals, and even how governments can organize auctions, to facilitate the adoption. And we talked about how it is important that we have strong supply chains. We talked about how are we going to ship it? Is it by ships? Is it by pipes? We've discussed all of these scientific, technological, and even policies that we need. So I thank our 4 speakers, President, Ambassador, Bernd, and Mr. Brand, Marius, for their participation today. Thank you, everyone. Signing out from Berlin, my name is Juliana Chan.
Yes, before you leave, just give me 1 to 2 more minutes. It was a busy day. Maybe you had the privilege to listen to all of the panels here, or maybe panels elsewhere. I was, as was Sebastian Turner, always, going around to check whether things were going well. So I got an impression here, I got an impression there. But my overall feeling was whenever I was listening for, let's say, 15, 20 minutes to these panels, I learned something. And I think this is due to just having obviously gathered a crowd of personalities that has something to say. So you are representatives of those panelists. Thank you very much here at this occasion for having been with us. You are a representative of the moderators. I think the moderators also did a great job, I mean, if you have such strong personalities who want to save the world, you need some guidance in the discussion. So I think the moderators also did a wonderful job.
Thank you, Chairman. Thank you. On behalf of all of us, thank you. Thank you for having us here.
There is now time to, I think, to get a coffee or something to drink. At about 6, we will divide into 3 groups. Probably you all know where to go. There was a long discussion how to handle, this welcome reception under pandemic conditions. But there is one boundary condition. We only can bring together at a certain location a certain number of people. And that's why we have to divide over 3 locations. There are some happy ones, like me, that only have to go from here to the Holzmarkt. And there are 2 other groups where buses are waiting in front of the Radialsystem and bring you to where you have to go. I don't know that. I hope you know it, and if you don't know it, just ask our people and they will tell you. So let's enjoy together the rest of being together here, and then a wonderful evening. There are, as Sebastian just said, in your badges, there are either blue or green little flyers that tell you where you have to go. So again, thanks a lot also for you as participants and also as question answers. Enjoy the rest of the day. Till tomorrow. Bye.